Welcome back everyone. In today's session we are going to see the most important concept of pair of linear equations, that is the concept of distance, speed and time. So we are going to solve a word problem and I'll give similar word problems to you for extra practice which are based on distance, speed and time. So everybody knows the formula of distance, that is distance is equal to speed into time. Okay, we are going to apply this formula. This formula is used in physics. You might have learned this in physics chapters. So this is also used in mathematics. So let's see how to use this formula to solve equation based on distance, speed and time. So here is the question. We have to form a linear pair of linear equations for this and solve it by any algebraic method, elimination method or substitution method. Let's see a question now. Places A and B are 100 km apart on an highway. Okay, one car starts from A, another starts from B at the same time. Okay, so we'll make a short story on this. Okay, suppose there were two cars on an highway which were 100 kilometers apart. One car was at point A, okay, which belonged to police. I'll say police. Another car at point B which belonged to thieves, those who have stolen something, and this car belongs to thieves. Just imagine it. Okay, I'm just making the concept clear to you with an example. So thieves looted a bank and they started running away. Okay, and first of all let me tell you the distance between A and B. This distance is 100 kilometer. How much? 100 kilometer. So police and thieves are at a distance of 100 kilometer already. Okay, and thieves looted a bank and they started running away. They started moving in this direction. Okay, and at the same time police also started following them. Police also started following the thieves at the same time. So they caught the thieves at point C, somewhere at point C. Okay, so who should be faster in this according to you? Police should be faster to catch the thief or not? Yes, so police has to be faster to catch the thief because they are already 100 kilometer apart. They have to cover this distance and they have to run behind the thieves. So distance traveled by police car is from A to C, isn't it? Police car traveled from A to C and thief's car traveled from B to C, BC, in say 5 hours something. Okay, this is the first case. You can see the first case. Places A and B are 100 km apart on an highway. One car starts from A, another starts from B at the same time. If the cars travel in the same direction at different speeds, they meet in 5 hours. So you can see these two cars are traveling in the same direction and they meet after 5 hours. Okay, in 5 hours the police is able to catch the thief. So this is the first case. Now we will apply the formula in this case. So let's, here police and thief is not there. Okay, that was a story framed by me for making you understand the concept. So police and thief is not there in our question. Now we'll begin. So then another case is there. Next there is another case. This is the car of police which is at A and another car of thieves which is at B. and this is the car of thieves, which is at B. Okay, and they are again 100 kilometers apart, same scenario, 100 kilometer apart. This is the second case. Okay, case number 2. So here what happened, after looting the bank, the thieves started running in this direction, means they were coming close to the police, and it was very easy for the police to catch the thief. They are going in opposite direction. Okay, they started traveling in opposite direction at the same time. The car of police and the car of thief, they started. So where they will meet? They will meet somewhere here. Okay, they will meet somewhere at point D, say point D. What is the distance traveled by car A? It's AD. The distance traveled by police car is AD, and distance traveled by thief's car is BD. So in this case, because they are traveling opposite to each other, they'll meet say in 1 hour, because they'll meet early, because they are traveling towards each other, coming close to each other by mistake. That was a mistake of thieves, and they get caught after 1 hour. Within 1 hour they were caught. This is our second case. Okay, so these are the two cases which we are going to see in detail. Hope the story is clear to you. First case, they were traveling in the same direction. Second case, they were traveling in opposite direction towards each other. Now coming to the question, let's see the second case here now. The second case, you can see, if the cars travel in the same direction at different speeds, they meet in 5 hours. That is the first case. If they travel towards each other, okay, this is the second case. If they travel towards each other, they meet in 1 hour. Now our work is, okay, just we know the distance between the cars and the time they travel. We have to find, using this we have to find what are the speeds of these two cars. So you have to sit in your classroom or sit at your home, solve the question and say what are the speeds of the cars. Isn't it amazing? Yes, very interesting. Let's begin. The problem is very simple. You need to frame the equations, then solve the equations, then you can get your answer very easily. So to begin with, I'll let the speed of the first car be x and second car be y. That is the speed of the police car be x, and the speed of the thief's car be y. I'll draw a picture for that. So this is the speed of this is turned in the wrong direction. Okay, this first case, the cars are traveling in the same direction. Just remember it. Okay. First case, the cars are at a distance of 100 kilometer already, and they are traveling in the same direction. So where they will meet? They will meet somewhere at point C. So this car is traveling in this direction, police car and thief's car. They meet at point C. They are caught here after 5 hours, in the time 5 hours. So distance traveled by first car. What is the distance traveled by the first car? Distance traveled by the first car is A to C, isn't it? Police car. That is AB plus BC. And distance traveled by second car, that is the thief's car, is BC. Okay. Police traveled from A to C, thieves traveled from B to C, and they were caught. So difference of distance traveled is AB plus BC minus BC, that is AB, that is 100 kilometer. Just keep this in your mind. Okay. Now how do we find distance? Let's see that now. Okay, distance traveled by first car minus distance traveled by second car. When you do distance traveled by first car, that is the distance traveled by first car is I'll say distance is equal to speed into time. Speed into time is the formula. So what is the distance traveled? We have to find distance traveled by the first car. So what is the speed of the first car? X. And what is the time it has taken? 5. So 5x. And distance traveled by the second car in 5 hours is 5i. Okay, distance traveled by this car in 5 hours is 5i, and distance traveled by this car in 5 hours is 5x. So what happens now? To find the distance, to find the first equation, we need to use the first case, this case, distance traveled by first car minus distance traveled by second car. So when you subtract this both the distances, just have a look here. Distance traveled by the first car minus distance traveled by the second car. What will you get if you subtract this part? AC minus BC. What is AC minus BC? That is 100 kilometer. So AC, distance traveled by the first car AC, is 5x, and distance traveled by the second car BC is 5i. When you subtract this both, you will get 100. Okay, so 5x minus 5i is equal to 100. And if I simplify it further, 5x minus 5i, if I take 5 common, x minus y is equal to 100 by 5, and x minus y is equal to 20. This is our equation number 1. Next one, this is the second case now. In the second case, I said you the police and the thieves, they are traveling in opposite direction. They are traveling towards each other and they meet at point D somewhere. So the distance between A and B is again 100 kilometer. So what is the distance traveled by car A? Car A travel distance AD, and car B travel distance BD. So here also I can frame equation by applying the formula. Distance AD is equal to speed of the first car is x, and what is the time? They have taken speed into time. So speed into time, that is x into 1, that will be x. And distance BD, distance traveled by the car, the green car, you can see, is distance is equal to distance BD is equal to speed into time. What is the speed of the second car? Y into how much time they have traveled? 1. Y into 1 is y. If I frame equations for this, distance traveled by the first car is AD, distance traveled by the second car is BD, and sum of the distances AD plus BD is how much? AD plus BD is nothing but AB, that is 100 kilometers. So I can write the total distance traveled by first car and the second car, that is equal to this will be plus here. Okay, just be careful. So this will be plus here. Okay, so speed of car 1 and speed of the car 2 into 1 hour. Okay, this is an extra step. If you want, you can write it, or you can directly write x plus y is equal to 100 kilometers. Okay, x plus y is equal to 100 kilometers. So our second equation is AD plus BD. Okay, here we add AD and BD and we get x plus y is equal to 100 kilometers. Okay, there we subtract. In the first case, this is only the most important point here. Here we do AD minus BC, AC minus BC. Okay, here we do distance AC minus BC. Okay, this is the distance traveled by the first car, AC minus BC is 100. Okay, when you do AC minus BC, you get 100 in this case. That is the reason we are subtracting. And here in this case, when you add AD and BD, you get 100. Okay, so we are adding distance traveled by distance traveled AD and distance traveled BD, that is equal to 100. So finally we have got two equations here. That is, first equation is x minus y is equal to 20 and second equation is x plus y is equal to 100. We will solve these two equations by any method, say elimination or substitution. Here it is done by substitution method. Okay, we are taking equation number 1. From equation 1 we are taking x value and putting it back in equation number 2, and we are simplifying. We got y is equals to 40 and x is equals to 60. So the speed of the first car is 60 kilometer and the speed of the second car is 40 kilometers. Okay, speed of the second car is 40 kilometers. Just ignore this and write 40 kilometers per hour. What will we write here? 40 kilometers per hour. So these are the speeds of both the cars, that is the police car and the thief car, and you can clearly see the police car is faster. That's the reason they were able to catch the thieves in the first case. Okay, ignore there are some corrections in it. Thank you.